Brilliant. So my name is Joanna Scales, and I'll be your chair for the first part of today's event on Quelea birds. Just some sort of general housekeeping points as we begin. Please do keep yourself on mute, as I said, while the presentations and speakers are going, just so we can all hear them clearly. And we will have opportunity for lots of conversation, and we'll make it clear when those sort of networking sessions are. Please do put your questions for the speakers in the chat, and we ask that speakers, if you're able, do respond to these in the chat there. Also, feel free to introduce yourself, your name, your organisation, what you do, or your interest in this event. Is always a good way to make connections in the chat as well. We will be recording today's session just so we can share it online, so you can watch back, and others can also have a look at the slides if they're unable to make it. But the networking sessions themselves won't be recorded. Next slide, please, Cameron. So before we kick off into the topic of today, I just want to give a really brief introduction to who we are. So Innovate UK KTN is part of the UK's innovation support system, and we really exist to drive change by building connections between innovators, exactly like we're doing today. We do that in the UK, but we also look internationally to make those strong connections. So today's event is part of a programme that we lead on as the agri-food team at KTN, which is called ACRE Africa Connect. So this aims to bring innovative people and organisations across the UK and Africa together to address key African agri-food challenges. And with today's session, what we want to do is give you all the opportunity to learn more about Quelea and the challenge that they present, hearing from a brilliant panel of experts today. I'm sure you'll have some awareness already, but Quelea birds cause significant damage to grain crops across the African continent. And there's a desire to ensure that control methods are able to be implemented both to stop Quelea from eating crops, to protect farmer and grower livelihoods and incomes, but also that these methods cause minimal damage to the environment. So with this event, we want to bring together a broad range of stakeholders and innovators to learn more about Quelea and the types of innovations that might be beneficial to support the goals I just mentioned. Following the event, we'll be launching a small number of small pots of funding for collaborations to explore innovations around control of Quelea. And we hope that the networking that we can do today will be of use in looking at novel ways to mitigate crop damage by Quelea, and also might form the basis of applications to these upcoming innovation awards. So for today's agenda, we have three main sessions. The first is really an introduction to the issue and looking at approaches to address challenges caused by Quelea. And it'll also include a panel session and a networking session too. Our second session is focused initially on monitoring and forecasting, and we'll hear from two key speakers there. And then we'll move into another technical session on deterrence and defence, before giving you another chance for conversation and a short break. And then the final session for today will be focused on agronomic and ecological approaches, so looking at crop breeding and ways to reduce loss through agronomy, with a final networking session finishing off the event and the day. So as I said, we hope that this is a chance for you to learn more about Quelea and this challenge they present, to explore ways that your innovation or work may link into this challenge, and to meet others to ask questions and explore the topic further. So with no further ado, I'd like to invite our first speaker, who is Professor Bob Cheke, who has spent his career really focused on Quelea birds. He's going to give us a sort of scene-setting presentation on Quelea, and a little bit of a summary of the types of control options that are currently being used and could be considered for use in the future. Over to you, Bob.
Okay. Good morning, everybody, and welcome to the webinar. I'm Professor Robert Cheke, Professor of Tropical Zoology at the Natural Resources Institute at the University of Greenwich. Just a brief explanation. the Natural Resources Institute absorbed the Centre for Overseas Pest Research, which was a UK government-funded organisation for work on tropical pests. And we had at one time Quelea pioneer researchers such as Peter Ward and Peter Jones. So I've recently been working on Quelea for a while with collaborators in South Africa and Tanzania. So next slide, please. So what I'm going to talk about is just a brief introduction to the biology of the bird, what is the problem that it causes, and how to control it. And I'd just like to point out that the main control method is still the use of the organophosphate pesticide fenthion, although there have been a lot of efforts to try to ban this. The Rotterdam Convention's Chemicals Review Committee has recommended that it should be listed in Annex 3 to the Rotterdam Convention as a severely hazardous pesticide formulation, and indeed some countries have abandoned its use, such as Botswana. So what are the alternatives to fenthion? That's the main topic of today. We're needing to find alternative solutions to control the birds. So I'll be looking briefly at alternative pesticides. The other main method being used currently, explosions, possibilities for repellents, cultural control, mechanical control in various ways. And then finally, I'll summarize what we've been talking about. Next slide, please. So this is what the bird looks like for those who don't know. It's called the red-billed Quelea, Quelea. Clearly has a red bill, but this is only the case in the males, and in the females, when they're in full breeding plumage, actually only have yellow bills, which is slightly confusing. The other thing is that there's a lot of variation in what the males look like, as they are polymorphic, and there are also different subspecies. Next slide, please. So this slide shows the different subspecies that occur. In West Africa, we have the nominate race Quelea. In Eastern Africa, Quelea ethiopica, and in Southern Africa, Quelea lathamii. Now, as you can see from this slide, one of the characteristic features of the Quelea birds is their long-distance migratory habits. And these, by and large, follow the rains, and we can talk about migration in more detail if necessary, but it is an important consideration when trying to forecast where the birds are going to turn up and where they might need control. Next slide, please. So the birds cause damage partly because of their massive numbers. As you can see in the picture, there's a photograph of a swarm of Quelea birds over some grassland. Now, grassland is their normal habitat. They feed on the seeds of wild grasses, but it's only when these are unavailable through drought or other problems that they will move in to start eating our crops. And the main crops which get damaged can cause losses of up to nearly 95 million worth of US dollars at 2021 prices. So in the dry season, they can still attack crops such as irrigated wheat. In the beginning of the rainy seasons, again, irrigated crops such as rice and the early ripening rain-fed crops. And then finally, in the rainy season, the rain-fed crops, in particular sorghum and millet, are often damaged. So you can see the pictures there on the left hand, some heads of sorghum. The two on the right have been completely devastated. They haven't got any seeds left. And the millet heads on the right, one is partially destroyed and the other is completely destroyed. So in general, any small grain cereal grown in semi-arid parts of Africa is a potential target, but bear in mind that they don't attack maize because the seeds are too big for their small bills. So again, pesticides and explosions are often used to control the birds regardless of whether they're actually causing any damage and regardless of the economics involved. Next slide, please. So more images of the birds themselves, but this illustrates one of their main targets, which is their breeding colonies. Another characteristics of the birds is that they breed in huge colonies of nests woven from grasses, but usually located in dense thickets such as acacia bushes with thorns, which are very difficult to reach. The other target is in the non-breeding season, when the birds accumulate in the evenings in massive roosts. Next slide, please. So who does the control? Well, in some cases it's national ministries of agriculture, in the case of Botswana, for instance, but there are also regional international organizations that have responsibilities for controlling Quelea in their member states. These include the Desert Locust Control Organization for Eastern Africa, from whom we'll be hearing later, and also the International Red Locust Control Organization for Central and Southern Africa. And indeed also some commercial companies are involved with the control. Next slide, please. So fenthion, as I mentioned, the currently mainly used control method is relatively cheap and very effective if sprayed properly, or used in combination with so-called trap roosts, which are the groups of vegetation grown particularly to encourage the birds to roost in, and then they can be sprayed. You can use either aircraft, which are of course very expensive, or vehicles to spray fenthion, and it's suitable for large areas, indeed more than 5 hectares. However, there is a case against the use of fenthion. Often people using it are not trained properly. This leads to the use of excessive dosages with concomitant environmental effects. You get sometimes fatal or serious poisoning of the operators of the sprays, and of course many non-target organisms get killed, such as the animals photographed there, a mouse bird, a weaver bird, and a snake. The other problem is that the pesticide persists in the soil with a half-life of 47 days. It is also unsuitable for use by small-scale farmers and cannot be used near water because of the damage it does to invertebrates such as crustacea. Next slide. There is another alternative that has been used to some extent called cyanophos, but the problems with cyanophos are similar to those for fenthion, since it's also an organophosphate, although it does have slightly lower mammalian and avian toxicity than fenthion. However, it also takes longer to kill birds, which may lead to increases in secondary poisoning compared with fenthion. By secondary poisoning, I mean that animals such as predators, such as hyenas or birds of prey, will pick up half-dead poisoned birds and then become poisoned themselves and accumulate the poison in the environment. Cyanophos is also persistent in the environment and is also just as damaging to non-targets as is fenthion. Other alternatives such as foxin and mefinphos are also really too toxic to be used. Next slide, please. The other main method used currently are explosions with various mixtures of petrol and diesel, which are strewn out in small containers underneath a roost or breeding colony and then detonated. They have the advantage over fenthion that they can be used near water, but equally well they have adverse environmental effects on non-target organisms. Obviously, an explosion is extremely dangerous, needing specialized personnel for their deployment and detonation. They have high security risks. Can lead to bushfires, and they're very difficult at scales more than, say, 5 hectares. Next slide, please. Some people have tried using repellents, and I think we'll be hearing more about them later today. For instance, the narcotic alpha-chlorelose has been added to baked grain or water in South Africa, and it could be used in urban areas, but of course there's a danger of non-target birds also getting affected. Similar considerations apply to mesurol, which has been used briefly on sorghum in Senegal and Sudan, where it reduced damage to some extent, but the compound is now banned by the European Union, so again can't be recommended. Other alternative pest repellents include the chemicals listed there, and again they're unsuitable for treating very large areas, so we need new repellents, and we look forward to hearing about those today. Next slide. Cultural control, type of integrated crop management, whereby you can arrange the timings of the planting such that the grain can be harvested when there are very few or no Quelea present. Now, this approach requires knowledge of the local conditions, particularly the migratory abilities of the birds. You need to know when they're going to turn up in order to make sure you've got your harvest in before they arrive in very large numbers. You can also use early maturing crops, but they may not always escape the attack and can be vulnerable for short periods, for shorter periods than the late maturing crops. So overall, you might harvest more. You can also use crop breeding to, for instance, encourage varieties with high tannin concentrations in sorghum. Now, this does work to some extent because the birds don't like it, but the problem is they just move to the next field where the non-resistant crop is being grown, and also the high tannin concentration in the sorghum means that people don't like the taste either. So, as an example of using the timing method for harvesting, in Chad and Cameroon, irrigated crops have been timed to be grown in mid-May to mid-June to avoid the arriving, departing Quelea birds. Similarly, in Ethiopia, irrigated sorghum planted in September can be harvested as early as December. Another method under the cultural control heading are physical control methods such as weeding to reduce the grass seeds, putting netting over crops, and bird scaring, and this is the method most commonly used by small-scale farmers as they have no alternative. Next slide, please. So examples of bird scaring methods used by villagers, such as banging on tin cans or using a loud cracking whip. There are commercial versions of bird scarers. Some examples are put there, which make an incredibly loud noise to scare the birds away. But again, it's not necessarily going to work because eventually the birds usually get used to the noises. Another method, also involving scaring, is the use of lanner falcons, and these have been deployed by a South African company to very good use in large sorghum fields in northern Botswana. Next slide, please. Another method which we hope to discuss today later are the use of drones. These can be used in a sort of swarm of themselves to attack Quelea swarms to frighten them off by emitting scaring noises. And also in the future, it's hoped that there might be possibilities for using drones to actually spray Quelea colonies or roosts. Next slide, please. A mechanical control method is very time-consuming, labor-intensive, but it does work by harvesting chicks from nests in these huge colonies, and particular examples have taken place in Tanzania, Zimbabwe, and Chad, which can be used by small-scale farmers. The advantage being that they can then eat the birds, so it's a win-win situation, although, as I said, it's unlikely to control a colony on a very large scale, but it does work for small colonies. You can also physically destroy breeding habitat and roosts by using tractors or simply smashing up the habitat, but again, environmental consequences. Next slide. Some trapping methods include the use of mist nets, and in Tanzania and Chad, various forms of traps are used. In Chad, they use very large nets held by two people underneath a roost or a colony. The birds are scared into the nets and then caught. And in Tanzania, these basket traps, which are illustrated, are used, baited with millet seed and a decoy bird. They can trap hundreds of birds, but again, a small scale, not a major control method. We've also tried using synthetic wire mesh versions of these traps, which were also successful. Next slide, please. So on this slide, we've got a comparison of the various things I've been talking about to try to compare the efficacy of a particular control method and their adverse environmental impact. So in the top right-hand corner, you have the organophosphate pesticides, which have very high efficacy, but also, of course, very high adverse environmental impacts. Explosions, not quite so bad. Repellents and habitat destruction, reasonably high effects on the environment, but rather low efficacy. And then the other methods are distributed around this graph. So it'd be interesting to know if anybody's got any new methods, where they would go on these axes. Next slide, please. So finally, it's important that all practitioners who control Quelea only do so when the birds are actually threatening the crop, and that they use the correct minimal dosages of approved pesticides. We need to improve forecasting. We'll be hearing about that later on from Rachel Dobson. And control planning. It would be ideal if we could have some sort of Pan-African system similar to the FAO desert locust forecasting methods. Each country could promote cultural control and support for integrated pest management, and also develop perhaps a decision support system. There was some progress on the decision support system development in South Africa. Another important aspect is to make sure operators are trained and the equipment is maintained and properly calibrated. And then also maybe you could promote small-scale methods such as the trapping, harvesting, which lead to the use of Quelea as food, which is actually a very highly nutritious protein source. Next slide, please. So we want also some research, possibly socioeconomic research, into what are the barriers against people using cultural control and trapping. Can we promote the use of Quelea birds as food more? Can we have more work on reconnaissance, perhaps using drones, and Pan-African forecasting, as I mentioned. We're also going to hear later on about novel biological methods such as avian contraception and the use of attractants. We also nowadays have the ability to track small birds with satellites, but nobody's yet done a proper experiment to confirm the migratory routes of Quelea birds using those methods. We need new repellents and new acoustic scaring methods. Next slide, please. So that concludes my talk. I hope I've covered the ground sufficiently for people who don't know anything about the birds to have an understanding of how severe and difficult the challenge of controlling the red-billed Quelea in Africa is. Thank you very much.
That's brilliant. Thank you very much, Bob, for such a comprehensive presentation. I think that gives us a really good introduction to launch today's event. So our next speaker, having sort of spoken about the broad challenge, is going to speak about how Quelea actually impacts the business and growers that they work with. So I'd like to invite Habiba Suleiman from Wacot Rice Limited, which is a rice processing company and part of the Tropical General Investments Group in Nigeria. And she's going to speak to us about how Quelea impacts their operations and the farmers that they work with. Habiba, I've seen that you're here, so if you're able to turn your camera on, Jess will be able to find you.
Okay. Hi, and good morning, everybody. Thank you so much for having me. And I mean, it was quite insightful listening to Robert speak about all of the issues, that we also are very familiar with. So basically, you've introduced Wacot, as a subsidiary, and Wacot is obviously Wacot Rice, runs one of the largest integrated rice mills in sub-Saharan Africa. And to source our paddy, we work directly with thousands of smallholder farmers who we train and support with quality agri inputs, capacity building, extension services, and also guarantee offtake at harvest. But obviously, amongst the major challenges, so I'll ask to move to the next slide. I think it captures some of the key issues. Okay, yeah, so this is an overview of our mill and what we do. You know, and obviously, like I said, we work directly with over 30,000 smallholder farmers, you know, a procurement outlet that spans across a huge part of the country, and then directly working with smallholder farmers in an outgrower program that is structured. So like I said prior, what we do in the outgrower program is we give farmers agri input at the beginning of the season. We train them. We have dedicated field officers and extension agents that support them throughout the process. And then we also guarantee offtake when they harvest, right? And obviously, key targets or key KPIs for us is obviously to increase yield, help, you know, improve their livelihoods and support, you know, transformation of the smallholder communities that we work with. But obviously, there are key challenges that we've been facing over and over again. So even with insurance, you know, to sort of control and mitigate some of these issues, you still have issues like flooding and erosion and pest infestation that remain incessant, you know, every season. Next slide, please. Okay, right. So unlike the other issues, and as you know, a lot of insurers would sort of avoid certain issues that are recurrent, and obviously a lot of them avoid Quelea. So this is something that is, you know, again, recurrent. This is something that we are unable to do something, you know, anything quite effective over time to really mitigate. We're very much sort of limited in terms of what we can do, right? And we've, like I said, worked to address yield issues, you know, and support smallholder farmers and train them. And obviously we've done so much work, you know, to help improve yield, but you would see that a lot of this is still, you know, is still very much relegated to the background when you're faced with Quelea birds infestation. So obviously FAO says they're the most important granivorous bird pests in Africa, and the population has increased from 10 to 100 times since the 1970s, right? And again, all the efforts, so government efforts, private sector efforts, have really had poor successes, again, because of the growth in their population. And this has led to significant losses, you know, in excess of $50 million annually. And what this has cost, or this has led to, is that a lot of farmers lose. And farmers, again, we're talking smallholder farmers who really just survive from season to season. And if they have, you know, a situation where there's lost one season, a lot of them are unable to recover. So far, mitigation that they've employed, you know, is birds carrying, like the Prof was mentioning, you know, use of the sounds, the noises, and pesticides and all of those. But again, this in most cases, you'd find that are detrimental to the environment and not sustainable and affect the environment and biodiversity. You know, so government effort that we've relied on so far is largely limited to, you know, the spraying of pesticides. But again, looking at how they migrate, and again, you have the cross-border thing where they move from one country to another, you really cannot predict when they will be moving next or how the migration pattern looks like. So again, everything we do is mostly guesswork. So we try as much as we can. I love that Prof mentioned that, you know, the early harvesting is one of those things that we've tried to encourage with farmers, you know, plant early so you can harvest early. But again, you'd have, even with farmers deploying all of those tactics, the scaring, the noise making and everything, the moment they leave the farm, the birds come, you know, in huge groups and destroy everything. And obviously the way they move, as illustrated here, you'd see that they can scavenge over a huge plot of land, you know, expanse of farmland within a very short period of time and destroy everything. And this is stuff that you don't have covered by insurance. So really, solutions are very limited so far. And there's a dire need, obviously, for research, you know, and innovation like the KTN is driving, so that we can obviously find new solutions. Because again, we don't want to get to that point where investors are deterred, you know, from putting into money into smallholder production and backward integration of agricultural products. Obviously, this is a huge issue for food security, and we would really love for there to be a solution that is sustainable, obviously for the smallholder farmers. Thank you. I think that's my last slide. Yeah. Thank you very much.
Brilliant. Thank you, Habiba, for putting it into context. So to sort of dive further into our sort of context setting, I'd now like to invite the Desert Locust Control Organization for Eastern Africa to speak from a a regional and a country perspective on how Quelea control is being handled currently. So I think Moses was going to speak, but I think his internet connection is not ideal today. So Joseph, are you there? And if so, please could you turn your camera on so that Jess can find you? There we go. We have you now, Joseph. So we've got your slides. So you've got just a couple of minutes to speak to those about the work that you're doing. Ooh. Not sure quite what's going on there. If we can't get Joseph.
He's muted.
Yeah.
Muted. You don't. How about
there
now?
you go, Joseph. We can hear you now.
Now you go ahead. Thank you. Good morning, everybody. My name is Joseph Maondege. I was the head of Quelea research at the Desert Locust Control Organization for Eastern Africa. I am from Tanzania, but residing in Kenya now. We have started an organization called CREMPA, Center for Research and Management of Migrant Pests in Eastern Africa. I've been asked to introduce a little bit about the Desert Locust. Desert Locust Control Organization is an interregional organization based in Addis Ababa. It is composed of 10 member countries in East and Central Africa. Namely, to the south, we have Tanzania, Kenya, Uganda. Then we have Somalia, Sudan, Eritrea, Djibouti, and Southern Sudan. In East Africa, Desert Locust Control Organization assists member governments in control of Quelea. As Prof had said, the control of the birds is the responsibility of governments. I could tell you why. Just to conclude my introduction here, I have worked for the Quelea since 1979. First, I was the head of operations in Tanzania. Then I joined Desert Locust Control Organization in 1985, where I've been doing research and management ever since until I retired in 2019. While I was there, I've been involved in the research and management of Quelea, as I've said. What Professor Bob Cheke had talked about, I was involved partly in the research of all of it, be it pesticides, crop, what we call a crop calendar, and others. And each and every one of those methods have got their challenges. One thing I want us to note is SGR2, zero hunger. Responsibility of producing cereal crops in Eastern Africa is not for government or big companies. It is the responsibility of small-scale farmers. And that's why the governments come in to do the control of the Quelea. Since Quelea attack the crop, farmers' crop, and they cannot manage to make it. So in short, that's what it is. I'm glad I saw my friend, Professor Cheke, whom we've interacted since 1917, when we were involved with FAO, Rotterdam Convention on pesticides. I will respond to that when time comes. But for now, since Bob has covered most of what is done, I don't know what you want us to do. But for East Africa, you should know that the cereal crops is a major crop for small-scale farmers. Very few big companies are involved, but when it comes to control, it's the government that is in charge due to the challenges that are involved with Quelea control. Thank you.
Thank you very much, Joseph. Good to have an understanding of the role that the government is playing within the control methods. So thinking about that, our next speaker is actually from Zimbabwe and is the Director of Migratory Pests and Biosecurity Control, which is a specific department that has been set up in Zimbabwe to focus on pests, including Quelea. So I'd like to invite Shingirayi Nyamutukwa to join us to speak to the role of his department in control of Quelea in Zimbabwe.
Thank you, Joanna, and good morning to everyone. Is it possible that you beam from there, or I can try sharing screen from here?
We are sharing your slides now.
Okay, thank you. Yeah, so I'm in charge of the Migratory Pest and Biosecurity Control Department in Zimbabwe. And basically our work involves a lot of migratory pests, including Quelea beds, locust, armyworms. But for today, maybe I'll discuss with you on Quelea beds. I'm just waiting. I can't see my slides.
Cameron, it looks like you don't have the slides. Let me share the slides here.
Okay, yeah. Oh, super. Yeah, so we can move on to the next slide.
Yeah, just give me 1 second.
All right.
I wasn't very prepared.
Okay.
There we go.
All right, just some introduction. Quelea is a serious pest of our traditional grains, that is the sorghums and millets, but also causing heavy losses on our wheat. But of late, recently, we have had Quelea beds damaging maize to an extent of losing about 25% of early planted irrigated maize crop. Last season, we had about 79,000 hectares under wheat, which is a record area under wheat production, and we stopped imports of wheat last year. And this year, we are targeting 85,000 hectares under wheat, which means we are expecting zero damage from Quelea beds in terms of trying to achieve our food self-sufficiency and nutrition. Next slide. So this just gives you an indication of Quelea breeding and roosting sites and crop damage that is due to Quelea beds. Next slide. So in terms of Quelea management in Zimbabwe, we mainly use chemical control, both fenthion and falcolan, but this is official control. In other words, we don't give the chemicals to farmers, but government officials are the ones who are involved in controlling the Quelea beds. And the chemicals can be applied by various means: motorized backpack sprayers, vehicle-mounted motorized sprayers, drone applied, or aerial sprays. Then we also have physical trapping using nets, and this is what we also intend to promote in future, usually targeting our youths, as they can harvest the beds for selling as a source of income. Then we also have bed scaring that we are also trying using drones mounted with speakers that have got a sound of a falcon bed. And then we also have destruction of roosting sites and breeding sites, but this involves a lot of tree cutting, usually by our communities, and probably having an adverse effect on the environment. We also have bed repellents, anthracnone, which is used by farmers, but this is directly applied to the wheat crop, but having disadvantages, especially when it rains and the repellent is washed off. Then we also have harvesting of nestlings during breeding season by our communities, but we are also working with the UNDP and Pegara in terms of laser technologies and automated trapping as safer ways of harvesting the Quelea beds. Otherwise, on a small scale, our farmers use what we call latex or urimbo from different types of trees. Next slide. So further, in terms of management, because of the impact of Quelea on maize, our farmers had to use physical barriers, as you can see in that picture, where they would cover the cob with a plastic bottle. But this is only applicable to a small area. You can't do that on a large scale. But then we also had kids using bed scaring tactics, like you can see in the left picture, but that also has an impact on our school children in terms of attending to classes. But in that picture, you see a harvest from physical trapping, and these youth are going to prepare this for selling. Next slide. So in terms of our future management, what we expect and assistance that we are also looking for, we are looking at artificial intelligence or innovations around area estimation in terms of the breeding and roosting sites. It's very difficult to come up with such areas, especially when you are moving in thorny areas. And then usually we provide estimates in terms of how many birds are in a flock, but if there could be any artificial intelligence to assist in bird counting, that would assist us also in estimating any losses that we are likely to incur based on the populations of birds. Also, assistance in terms of bird tracking and movement behavior. This will also assist in our early warning systems, but also in assistance in terms of food loss calculations based on populations of Quelea birds in an area. Then in terms of physical nets, as you can see on the left picture there, we would expect that if we get assistance in terms of many of these nets, we could actually train a number of youths who can be involved in harvesting Quelea birds in a safer way for consumption as a food and protein source. We are also looking at mobile applications for real-time reporting and capturing of Quelea bird events. I know with Locust, we have got the eLocust 3M, with the Folamwem, we have got the FAMUS, but I think if we can also have a mobile application for real-time reporting by our farmers and extension staff, this would also assist us in timely response so that we prevent heavy losses. But we also expect to work on bird reflectors as an alternative to chemicals for Quelea control. Thank you.
Thank you very much there. So we're now taking it a little bit of a shift. Cameron, if you're back on screen sharing, I think there.
Yep, I think that's right.
Perfect. So I think we should now be moving to hear from Pegara, which is a AI company based in Japan. So Aiko, I'd like to invite you to turn your camera on and we'll spotlight you. And so Pegara are involved in a project in Zimbabwe where they're looking at ways to integrate different technologies together to reduce damage by Quelea. So I think quite a nice example of how innovations are being applied in combination to reduce the damage by the birds. Aiko, over to you to tell us more.
Thank you, Joanna. Hi, good morning, everyone. I'm Aiko Watabe from Tokyo. I'm working in Pegara Inc., and I'm a product manager at Pegara Japan. So today I'm going to introduce our project. Before I begin, let me simply introduce the company. Next slide, please. Pegara Japan is located in Tokyo, Japan. We develop and conduct research into AI technologies. We are using technologies called deep learning to analyze image and video data to create products that can replace the human eyes. We are currently participating in Japan SDGs Challenge, a project organized by UNDP and collaborate with private company in Japan to resolve social issue, and to that end we are started activity in Zimbabwe from this year. Next slide, please. As others have already explained, the Quelea bird is causing extensive damage to grain crops in Zimbabwe. They grow very fast and the countermeasures have not been able to keep up. Next slide, please. At the beginning of the project, we proposed a solution using the green lasers. The proposed system utilizes AI to recognize birds, will fix camera, and use laser light to drive them away. We traveled to Zimbabwe this March to test this proposed solution. However, after testing the laser at the bird, we found that this method is not effective. We have found that we need to break down the issue into smaller pieces. Next slide, please. We divided our approach into 3 different parts. First, allocating the bird. Second, driving the bird away. And the third, capturing the bird. Next slide, please. First, the location of the bird. The bird moved between 3 locations. That is their roosting site, breeding site, and farms. Identifying the location and number of birds is critical to developing countermeasures. We placed the fixed AI cameras in location with good view and use a drone equipped with AI camera for location that are inaccessible to humans. We are in the process of analyzing the data we obtained in Zimbabwe last month, but it is clear that we will need to collect a more large number of pictures that clearly show the birds. Next slide, please. Second, method to drive the bird away. After speaking with local farmers in Zimbabwe, we decided to focus down the 3 methods that seems to work. The first solution is deploy speakers. Local farmers use a plastic bottle filled with stone and they shake it and to make noises to scare away the bird. That was effective, so we want to use the method. The second solution is to deploy water cannons. Since farmland is often located near lake, so we thought that equipment such as a water cannon or fire hose could be used on the birds. The third solution is deploy high-power lasers. Low-power lasers were not very effective in our on-site testing, but we believe that high-power tests could be used in the evening as well as at night. We are considering equipment drones with AI camera with these devices. Next slide, please. The third step is capturing birds. The bird breed at a very rapid rate, and we need not to only drive them away, but also kill them in order to fundamentally solve the problem of crop damage. This bird is also an important source of protein for local people and is sold at many markets. Locally, the bird are generally caught using a net, but since the number of birds is so large, we believe we need to create a system automate this process using technologies. Next slide, please. We plan to test this solution in Zimbabwe in this June to August. This is a time of year when grain damage is most severe, so it will be easy to see the effectiveness of the solution. Although the project had just begun, we remain committed to developing effective solution. Thank you.
Thank you very much, Aiko. So having in the set of talks we've had so far heard a bit about the bird itself, an overview of possible solutions and how integration of these is both hard and complex from Aiko at Pegara there. We're now going to take a bit of a step back to think about this from a conflict perspective. So our next speaker is Nils Bunnefeld. He is a professor at the University of Stirling, and he's going to speak about a few case studies of approaches to address agriculture and conservation conflicts. And I think this perspective is really important when we're looking at the role of innovation and solutions to Quelea control, and particularly how control, conservation and food security intersect within an African context. So over to you, Nils.
Thank you, Joanna, and thank you for all the previous speakers who have put this really nicely into perspective. So we have heard already that the community is already suffering major losses from this bird, and we've also heard, on the other hand, that some of the control methods have a huge environmental and kind of conservation impact on other species. So there's a huge loss and a huge impact on this. There's also sometimes an impact on human health. So we're really kind of in this situation where we need to look at methods of controlling this bird, and also ensuring at the same time that we don't or that we minimize the harm to other species, the environment, and of course the people that live in this environment. Next slide, please. So I'm very much kind of looking at conflicts between different stakeholders. So, or sometimes trade-offs or conflicts that happen because we have, for example, to start with maybe a latent disagreement or expressed disagreement, how we should control these birds. What is the best method really to tackle this problem? Quite often what happens is that we can have also then action, or multilateral or unilateral action, even violence in some cases in conservation, where people really fundamentally disagree how we should tackle a certain problem. And my research is really concerned with, like, how can we bring these conflicts back to some kind of collaboration, really the lower bar, the blue bar. That's what I'm interested in. How can we bring back people that have kind of all very good intentions and an interest in a certain landscape, in agriculture, food security, and also conservation. How can we bring them back together and reduce these conflicts? Next slide, please. As you can see here, these conflicts are really ubiquitous. They happen around the world. They often happen when species destroy crops, or when they have an impact on livestock, somehow impact. So you can see here that you can see it's happening around the whole world, but it's also going up and down. So we see a lot of red happening in these case studies over time, but we see also kind of blue again, where the conflict comes down and we go back to cooperation. So my interest is really, how can we manage these kind of case studies? Next slide, please. So the question really is, how can we, when we have a conflict between different stakeholders, what are agents of change? How can we bring change to these kind of conflicts between people over a certain resource and agriculture conservation conflict? What are the spaces that we can deliver to that deliver solutions? And finally, how can we kind of transform the agriculture conservation system? So in this case, just to illustrate what we have done in terms of research, I would like to go into two case studies, and that's the next slide, please. So here what we've done, we have done two case studies with farmers in Gabon that suffer from crop damage from elephants, and we have done a similar case study on geese, also damaging crops, agricultural crops in Scotland. And the reason why we did this case study is to see whether we can find patterns, general patterns, how people perceive this as a conflict, or how people wanted to cooperate. So what you see in front of you is a kind of mini game where the little sticks are kind of your agriculture. We sat around laptop computers or tablets, and we asked all these 4 players around the table to make a decision, whether, in this case, for example, elephants, whether they wanted to shoot the elephants or scare them away, or farm, or put habitat aside for conservation for these elephants. We did the same, exactly the same kind of study with geese, but otherwise it looked exactly the same. So we wanted to see how do people then, for example, react to the damage they create, the subsidies that we maybe can add to the game or to the real system, and we wanted to see how people make these decisions. Next slide, please. And here you can see some examples. You know, red means scaring. Then we can also kill the elephants, and you can see how the landscape forms and different players make different decisions. We also asked these the farmers lots of questions about the loss they have experienced. We asked them about the subsidies. We asked them about their kind of livelihoods. And we asked them also about the relationship between them and government officials, and the relationship between them in the community. Next slide. So what you can see here, the game results from Gabon, is we asked them how much they perceive the management of elephants as fair. Do they have a say? Do they feel that resources are fairly distributed? And what we see here is, like, when you look at the red dots, so to speak, we can see at low equity, we really see an effect of subsidies and help with deterrence and general help. When they perceive that they don't have a say, when farmers perceive they don't have a say, and they have this kind of low fairness, then we see an effect of management activities such as adding subsidies or helping them with deterrence and so forth. And that really translated into a reduction of killing protected elephants. So we really see an effect of this kind of fairness now on kind of conservation decisions, basically. Next slide, please. In Scotland, we have a really interesting effect as well. We have on the x-axis at the bottom, you see community trust. And then on the y-axis, you see the proportion of decisions to shoot geese, to get rid of the geese. And what we see here is that when people in playing this game and in our research, when they had very low community trust, negative numbers, they wanted to see a lot of these birds killed, and they just were frustrated with the system. But when they had a lot of trust in the community, they worked together and they discussed the problem. They found lots of different solutions to the problem, and killing the birds was one option, but not the only option of management. Okay, so next slide, please. So, that has moved around a bit. Sorry about that. So these are 2 very quick case studies because we don't have to have a lot of time now to go into a lot of detail, but it's part of a framework to transform these kind of conflicts. And conflicts often happen because of power imbalances, but also having agency, so perceiving that we have a fair distribution of power. They often happen because of narratives. People get into a kind of narrative, this and this is really bad, and we are here in a conflict with these and these agencies, or something like this. So these kind of conflicts happen because of these kind of factors. What we can do, we can produce agents of change, and trust and equity fell at you can't see it now, but the trust and equity and fairness are clear agents of change. And so is integrating the science, the policy, and the practice, really not seeing these pillars as completely isolated, but bringing them together, it can be an agent of change. And we need these kind of bottom-up community approaches together with the top-down approaches. We really need to come together and produce this kind of agents of change. And then, of course, we have solution spaces. We have innovation. We heard about innovation a lot today, but we also have knowledge co-production. We need to produce this knowledge together at the interface of science, policy, and people on the ground. We need to empower people, and we need to kind of learn together to provide these spaces to find solutions. And that really then can lead to a transformation of the social ecological system, the agriculture conservation system. We can then experiment and adapt and really find the best solutions that fit the local context. That does not mean that conflicts don't reappear, of course, because of narratives or things that go wrong, but we can go around this cycle again, look at the agents of change, the solution spaces, and hopefully thereby transform the entire system and bringing together the kind of technological innovation that we've heard so much about today, together with the social learning and empowering the communities. Next slide, please. So for my studies, equity and trust, so fairness and perceptions of trust are really important enablers of community-based approaches to manage these conflicts that often happen at the interface between agriculture, biodiversity conservation, and food security. And I believe that these approaches and the community approaches and the conflict resolution approaches are underused in global and local policy and management. They can really help us to bring people together that want to achieve change and that want to achieve a cooperation between organizations and people that have a very common interest. Thank you very much.
Thank you very much, Nils. Really interesting perspective on the challenge. So I'm leaving you spotlighted because we're now going to move into a short panel session to give us a bit of a chance to hear more from our speakers and maybe to ask them a question or two as well. So if you do have a question for our speakers, please do drop it in the chat now. So I'd like to invite Bob, Habiba, Shingirayi and Gift Natuli as well to join Nils and I up on this virtual stage. So if you could turn your cameras on, Jess will be able to find you and spotlight you there. I'll give you a moment. And while Jess finds our panelists, I'd just like to give a brief introduction to Gift Natuli, who's joining us and hasn't yet spoken. He's from the UNDP Accelerator Programme in Zimbabwe and is working closely with the Pegara project that we heard Aiko speak about a little bit earlier. Perfect. Do you want to take the slide share down, Cameron, so that we can see our panelists? Perfect. Okay, so before we continue, just a thanks to all of our speakers for this morning and to you as well for joining this panel. It looks like we're maybe missing Shingirayi, but if you could turn your microphone on, then we'll be able to hear from you. So really, I guess my first question is very broad. So maybe I'll go either to Gift or to Shingirayi first on this. And it's, what do you want to see in the future with regard to control of Quelea? Gift, I don't...
Yeah, thank you, Joanna. And it's nice to meet everyone. As Joanna said, my name is Gift Natuli, working with UNDP Zimbabwe with support from the Japan Innovation Network. So in terms of what would want to, or what I envision the situation should be for Quelea in Zimbabwe, I think I'll reference the small rural communities that are being impacted by Quelea, where when we went out in the field and interviewed them, there was general agreement that they would want a future where Quelea birds can be sustainably turned into a source of protein for the rural communities. So really, for us, a sustainable future is a future where Quelea birds move from being a pest to actually being a nutritious source of food. And how do we do that? I think that's what we're trying to work on, and that's the reason why we're here, where we're asking ourselves, how can we sustainably capture Quelea birds in a way that they're safe for human consumption, and also we're able to do that in a manner where we can reduce the numbers. And yeah, that's how I'd answer that question in short, Joanna, thanks.
Mm-hmm. Habiba, as a sort of industry player, what would you want to see sort of your role being in the future? Oh, you're on mute, sorry.
Yeah, so I was saying, I mean, there's obviously need for collaboration, right? There's a lot of problems, as you can see. Everything we've done so far has not worked. So our hands are somewhat tied, right? And I'm thinking, obviously, there's need for even cross-country collaboration, because as you see, they migrate cross-border, right? So if, for example, in Nigeria, we're doing what we're doing, and then the neighboring country is not doing the same, or we're not collaborating on how to work together, then we probably would not even be achieving anything at the end of the day, right? So I think, and the private sector, obviously, we're very much about working directly with these farmers. So we're open to deploying and implementing any new solutions that are discovered, and even testing, so that's where we see ourselves. We would obviously be working also to enlighten farmers. Obviously, a lot of the speakers have mentioned the environmental consequences and impacts of pesticides, increased use of pesticides. A lot of these farmers do not know the impacts, or what dangers there are. They just want to protect their crops. So there's really more to do. And we really hope that we'll continue to be part of these conversations as we seek solutions moving forward.
Yeah, we've got a question from the audience related to your point there, Habiba, which is, if a solution is successfully piloted, who would be the future customer? So would you see yourself as a buyer, as a customer, or do you think often farmers themselves could be a buyer of solutions?
Well, I mean, that also depends, affordability is a key factor. So again, obviously, private sector, I feel, is best positioned to, purchase, as the case may be, and deploy, to farmers and help farmers. So yeah, we would most likely be in a better position to secure the solutions and deploy to the farmers that we work with.
Mm-hmm. Yeah, thank you. Would anyone else like to touch on that initial question of a sort of a future view over Quelea control?
Hello, Joanna. Moses.
Hi, Moses.
Moses Mafabi has joined in. How are you?
Good.
Yeah, maybe at some point I'll have to say something on the panel discussion.
Mm-hmm.
Want me to go ahead?
Yeah, so Moses is from the Desert Locust Control Organization of East Africa. So he was meant to be our speaker earlier. I'm not sure your sound is very good, Moses, so I'm not sure we can hear from you.
You can't hear?
No. So I think my next question then is, what do we see as the major challenges to getting to the implementation of the control methods that we've been speaking about today? So are the challenges around the technologies themselves? Is it, as Nils was sort of beginning to touch on, the stakeholder and cooperation element? Or is it data and knowledge that's a gap to getting to sort of a future where Quelea bird impact is reduced? Maybe I'll go to Nils to touch on that initially.
Yeah, thank you. Thanks, Joanna. I think the challenge really is to bring these two together, right? Like to, on one hand, enable and improve trust between different stakeholders that have different interests, that have maybe also knowledge on new ways of controlling these birds, bringing them together. I think that's really often a real issue, I would say, that we need to overcome. And then ideally what we would do is we would then test and to some degree experiment and actually have people that will then monitor these kind of maybe mini experiments and say, okay, so we've tried 2 or 3 different options, and we have now monitored the data, we have collected that data, and now as a consortium of lots of different people, we're then kind of really evaluating what we have. But for this, we of course need to accept that everyone is happy to share knowledge, share data, and also is open to different solutions. So we have to kind of overcome this kind of perception that one group wants to do this and another group wants to do this. So I think that's an often overlooked aspect of this.
Yeah, thank you. Bob, I don't know if you've got a comment on that.
I don't think so particularly, but can I take this opportunity to pick up on a few questions that turned up in the chat?
Oh yeah, definitely. Go for it.
First of all, Martin Sharp has asked about commenting necessarily on the laser thing. Now, I don't really know much about this, but I imagine it probably would work if the birds get scared by lasers. I think this has been used against gulls and pigeons. But the only problem is I imagine it's quite expensive, possibly difficult to deploy in African circumstances. Another question is from Ephrem. Does the distribution of Quelea relate with some evolutionary advantages, if any? I think there's definitely a yes to that. The migrations clearly are adapted to maximize their ability to exploit the local resources, bearing in mind that the natural evolution was in relation to how the grasses start seeding when the rains fall, and so they're adapted to move where the seeds are not yet germinated to move to where they have germinated. And because they can therefore, by migrating, exploit grain resources in numerous different parts of Africa within the same season, this allows them to breed in successive migratory jumps, and therefore their reproductive abilities are very high. They may indeed breed as many as 3 times in one season in some places. So again, a definite yes to that. And Wim Moulier, hello Wim, has criticised where I put the cultural control methods on the graph at the end, putting them in the lower left. Okay, that's slightly subjective, and I agree with Wim that maybe the cultural control method should be increased in their effectiveness, and as he suggests, by better synchronization. And he's also talked about raising the issue of insurance policies. This is a method that has been argued for by many people, but my personal view is that however good your insurance policy, that doesn't feed people, and it's no good getting a big paycheck after your insurance policy coughs up if you can't actually have any food to buy. The crucial thing is the food production. But of course, in some circumstances, if the insurance would allow buying imported food quick enough, that would resolve it. Okay, I think I've covered some of the questions. Back to you, Joanna.
Yeah, brilliant. Thank you. And insurance is something that we'll hear from in our next session. And I know, Habiba, you had touched on that as well. I don't know if you've got any sort of comment on that you've got, insurance provides you money, but doesn't necessarily provide you food. Hope you're right.
Yeah. So, I mean, you would see that a lot of these issues are somewhat compounding to an extent. You have insurance, but then again, because of the magnitude of the impact of destruction that these birds cause, insurers are avoiding, that sort of cover. And again, if you want to move full cover for smallholder farmers, it's very expensive. It's going to take off maybe up to half of their earnings, right? So it's somewhat of an issue. I saw someone mentioning cutting down trees. How does that? Again, we started an agroforestry initiative for our rice farmers because we saw the impact of flooding and erosion and how it was destroying, farmlands. And we sort of drove that initiative. And then the farmers were saying, look, these trees are where the birds are going to come and, stay. And that's a serious issue, right? Because again, you're seeing that there's a lot of issues that are happening at the same time. You want to plant trees because you're seeing erosion and flooding, but then farmers are telling you, but these trees would allow for birds to come and roost and destroy my farms. So I think there's got to be a multi-pronged approach where we're looking at these things from various angles, right? What do we do to avoid or tackle this issue without allowing for another issue to escalate, while that is happening? Another thing I wanted to add, obviously, is that cultural methods, like I think Nils was mentioning, have been there. What do we want to do to investigate what has been happening prior to now and see what to do to modify and optimize and even scale in most cases, right? So what has been happening culturally that we can build on, that does not affect the environment, that does not involve extensive use of pesticides and all of those sorts of things, And then another thing I was thinking of the top of my head was, are there any predatory birds that we can deploy that would prey on these birds and sort of maybe even help in population control? I don't know. But, that's something we may want to explore, just to, because again, the growth in population, the way they breed very fast, what do we do to address one issue without allowing for another issue to escalate while we're at one side of the thing? Thank you.
Thanks, Habiba. Nils, you've had your hand raised for a minute or so. Do you want to jump in there?
Thanks, Joanna. Thanks, Habiba, for mentioning, kind of bringing it back to what I said, because I just want to bring it also back to the laser and some of the other options. We already saw in the chat that deploying laser solutions can be expensive. The other aspect of this is, does it work in other parts of the world? The technology, yes, of course works, right? I mean, birds are scared of laser, and I've seen this many times, for example, here in Scotland with geese, thousands and thousands of geese. I mean, you have to imagine on a small landscape, 20,000 geese, they're large birds, they eat a lot. So it does work, they're very scared. But you also have to think again about the community kind of approach, because if you're in a community, in a landscape, the only one who has a laser and uses that laser, you'll be up all day and night lasering these birds. However, if you have this as an integrated approach and you agree with many others in the community to cooperate on this, then of course it's a very different effect. You really introduce disturbance that affects the feeding rate of these birds, affects their fitness. So you really have an effect, but you have to think of it as a cooperation and collaboration. So whatever you do, I would say, you have to get together and think, how can we make a landscape scale plan rather than everyone working on their own and having their own kind of mini solution. Thank you.
Thanks, Nils. I think based on the time, and I think based on the ending on a high there in terms of the requirement to bring together communities, to bring together a range of stakeholders and work across borders, I think I'm going to call an end to this panel session, and we'll go to a short break. So thank you very much to all of our speakers this morning, to all our panel too. We're going to take a break just for 10 minutes until 11 o'clock. So time hopefully to grab a cup of tea or coffee, have a short breather. And at 11, we're going to be focusing first on monitoring and forecasting, and then on deterrence. So really diving into some of the innovations that have started to be spoken about in this first session. So we will see you back here at 11 o'clock.
Especially on the ACRE Africa Connect project. So our second session of the day is focusing on monitoring and forecasting. We're going to look briefly at how this can contribute to improving control and reducing the impact of Quelea. Next slide, please. So first up, our speaker is Rachel Dobson, who's a researcher at the University of Leeds, looking into early warning systems for Quelea distribution. Rachel?
Hi, thanks Cameron for the introduction. So yeah, I'm Rachel from the University of Leeds, and I'll be talking to you today about my forecasting system for Quelea. Can I have the next slide? The next one. So yeah, why is this important? Well, if we are able to forecast where and when Quelea are going to be, then this can allow us to implement more proactive management strategies, which are often much more efficient. For instance, if we know that colonies are likely to form in a certain area, then we can begin searches for these early and deter them before they have time to reproduce and have a large population and before crop damage occurs. So hopefully by developing this forecasting system, we can maybe reduce the use of pesticides as well, which harm non-target organisms, but also we can improve the efficiency. Next slide, please. So what have I been doing? Well, I've been focusing on forecasting Quelea distribution in Southern Africa. And to do this, I've first collated historical Quelea occurrence records, so from citizen science organizations as well as pest control organizations. I've then extracted for these records different environmental variables from remote sensing datasets, so looking at precipitation and temperature. But also, as I've highlighted on there, I wanted to really target the ecology of Quelea. So I used remote sensing data to extract wild grass and cereal crop seed availability, and this became one of the best predictors of Quelea distribution. So then I modeled the relationships between where Quelea are found and these different environmental variables. And by doing this, this allowed me to then get forecast data for these variables and project suitability onto these forecasts. Next slide, please. So how I evaluated the forecast is I use this process called hindcasting, where you essentially do the forecasts, but in the past. So then you can compare your forecasts to what we know actually happened in that historical period. So if we just look at the left panel, the first column is the remote sensing data projections. So this is on what we know happened at the time and is what I consider a gold standard for Quelea distribution in these time periods. Then the second column along is the forecast at 1 month ahead, and the third column 7 months ahead. So as you can see visually, it's quite similar at 1 month, but 7 months, it's not as close. Next slide, please. So this is basically quantifying what we saw on that other slide. So I calculated the correlation for each grid cell between the gold standard remote sensing projection and the forecast of Quelea distribution suitability at 1 month, 3 months, and 7 months. So with 1 being perfect correlation and 0 being no association between the gold standard and the forecast, 1 month we're getting 0.70, which is quite strong. But by 7 months, this is deteriorating to 0.59. So the forecasts 7 months ahead just aren't doing as well at forecasting Quelea distribution, but at 1 month, there may be quite reliable forecasts. Next slide. And so I was interested to see exactly what was underlying this kind of deterioration as the lead time of the forecast increased. And as you can see, one variable really stuck out. This wild grass and crop seed availability variable, which was the best at predicting Quelea distribution, was also the hardest to forecast. And really by a lead time of 3 months, it becomes impossible to forecast under 0.3 correlation with what we're actually seeing from the remote sensing data. So yeah, this is probably quite a big challenge. Can I have the next slide? So here I've just highlighted some of the major challenges to this forecasting system development. Firstly, we have the challenge that's associated with forecasting remote sensing variables. So especially if we want a warning of Quelea 7 months into the future, we maybe need to improve our way that we can forecast certain variables, particularly more ecological than the weather forecasts, which are quite strong. And then I think one of the major other challenges I wanted to talk about was the practicality. So I can develop these forecasts, but they're not useful in actually improving Quelea management unless they're actually reaching the stakeholders who are going to use them, so the people that it's important to reach. So this is one thing I'd really like to kind of going forward improve on, is look at how I can get it from my computer to the people who need it. And another challenge that's associated with this is keeping the models updated. So I want to keep to improve the model's accuracy as you keep updating it with new occurrence records of Quelea coming in, and also automating them. So even after my PhD's ended, the forecast can keep being automatically generated as new forecast data become available. Next slide. But overall, it's a really great opportunity. I think the forecasting system could really help improve our efficiency of Quelea management. And as we're seeing improvements in the data quality and the forecast data, particularly as the resolution's improving and our ability to forecast weather into the future is improving, this should hopefully drive improvements in the Quelea forecasting model too. But yeah, the takeaway message is, for these forecasts really to be useful, they need to be accessible by the stakeholders. Next slide. So thank you all for listening. Thank you to my supervisory team as well, and NERC, who are funding my PhD research. Thank you.
Thanks very much, Rachel. What a fascinating presentation and really valuable project. One interesting application of the forecasting and monitoring stuff discussed by Rachel could be around using that information to support in the provision of crop insurance. So next speaker is Samuel Macharia from ACRE Africa, who will be presenting on approaches to smallholder farmer agricultural insurance. But Samuel, I understand that you were looking to use a different set of slides, which are here. Thank you very much, Joanna. So Samuel, take it away.
So good morning, everyone. I'm Samuel Macharia. I work at ACRE Africa. I do business development. And I also assist the team in underwriting and loss assessment for agriculture insurance. So ACRE Africa ACRE is an acronym meaning Agriculture and Climate Risk Enterprise. We design insurance product for smallholder farmers. We also assist the whole entire value chain for agri insurance. Apart from product design, we also do crop monitoring, we also do loss assessment. And our main shareholder is ZEPRI or PTA Reinsurance. So far, we've covered over 5 million farmers since 2009 when the company was formed. We have presence in Kenya, Rwanda, Tanzania, Ethiopia, Malawi, Zambia, Nigeria, Ghana, Senegal, and so many ASAL regions like Somalia, Ethiopia, where we have this drive project. Next slide. Well, over 700 million people in Africa depend on agriculture, and out of the 700 million people, well, a very small percentage of them are actually insured. 90% of the agriculture activities in Africa is rain-fed, and despite the biggest arable land available in the world being in Africa, Africa spends $35 billion for imports of food. 2% of the GDP of Africa is from agriculture, and so agriculture is one of the major pillars in the African continent in terms of the economy. Next slide. So I'll give a Kenyan perspective of the 2021 statistics for agriculture. The values you see there are in Kenyan shillings, but I can try to do a quick conversion to USD. So in 2021, Kenya did $3.5 million for crop. They also did $4.2 million for livestock, and the total was around $7 million in terms of premiums earned. For claims, we had $1.3 million in crop insurance claims and $1.3 million for livestock claims, bringing the total to around $2.7 million. Next slide. So Well, how is crop insurance used as a de-risking tool for smallholder farmers? The penetration for agri insurance in not only agri insurance in Kenya, but insurance in general in Kenya is very low. In Kenya, I think the penetration for insurance is at 3%, and 89% of Kenyan farmers have not been insured and do not have any access to any agri insurance product. Just to give a rough estimate, in the drought of 2008 to 2011, the Kenyan economy lost around $7.3 billion to drought, and that is what initiated the Kenya Agriculture Insurance Program. It's a project that was initiated by the Kenyan government to cushion smallholder farmers in the events of drought, and they thought that the government thought that by insuring the farmers, they would at least invest the 7.3 USD they use for drought mitigation to other development projects. Next slide. Well, why don't, as one of the speakers said, we do not have any insurer or reinsurer who is willing to do cover for killer birds. The reason is because, first of all, we do not have enough data for the effect of killer birds in the country. For example, give an example of Kenya, meaning that since we do not have enough data to support the effect of killer birds on crop, we cannot then be able to design a product for killer birds. The other one is that the killer birds event is catastrophic. Very catastrophic, I mean that it can contribute to losses of around 70 to 80% of the produce in the farm. Meaning insurers shy away from covering the product because the agri insurance premiums in Kenya are very small, and so the fact that the premiums are very small, it means that the agri insurers in the country do not want to be involved in the insurance of the insurance against killer birds. The other thing that hinders the growth, the one that hinders the development of a product for killer birds is that the Kenyan law is very strict on how you can control wild animals, and killer birds being one of them. It's very difficult to start spraying, for example, without government permit and things like that. So it becomes difficult for farmers to control, for example, using chemicals, as has been said by the previous speakers. And so as an insurer, you do not know where to draw the line between negligence and accidental losses. Next. Well, are there opportunities if we are able to, for example, in rice farming in Kenya? I decided to choose rice because rice is one of the crop that has a huge potential in the country. And in Kenya, for example, so far in 2023, I think we have a deficit of maybe a million tons of rice, which have to be imported maybe from Pakistan and Asia and Asian countries to come to the country. So what that means is that we have a huge opportunities for growth in the country for rice farmers because already there's a deficit. And so it is very important to create what I call market-driven crop farming, whereby you have a demand for a certain crop and farmers know that once they grow the crop, they have an immediate market. So there are a lot of opportunities in rice farming. Next slide. So what should actually happen? Talk of opportunities is that what should actually happen for us to maybe at some points create a product for killer birds. As I said, the demand for rice is there. So meaning the demand for production is also there in the country. We do not have enough data, because if we had data supporting and saying that the effect of killer birds on a rice field, for example, is to this extent, then we can actually be able to differentiate when the effect is as a result of negligence and when the effect is actually accidental. And then also we need to come up with a rice mitigation protocol, whereby we say, when I talk about a rice mitigation protocol against killer birds, I mean, we need to have like a standard way of saying that farmers who are in areas that are prone to killer birds need to put in the certain measures, which should be standard across maybe a region, county, or maybe a province or district, for example. And then from there, we can actually be able now to draw the line between when the losses are as a result of an accident or when the losses are as a result of negligence. So it's very essential that you come up with a risk mitigation protocol that we share with our farmers and train them on how to mitigate against killer birds. And if we get to a point whereby we have a standard risk mitigation protocol, I think insurance companies and reinsurance various companies across the country would be willing to get into the space for ensuring killer birds. Next. Thank you for your time, Samuel Macharia.
Thank you, Samuel. That was a really fascinating presentation, and it's really valuable for us to hear from the insurance side of things, which is obviously so important. So that actually brings to an end our mini session on monitoring and forecasting. Next, we're going to be moving on to looking at deterrence and defense innovations to reduce crop damage from Quelea. It's important here to consider not just the innovations themselves, but also how they can be incorporated into the landscape and their effect on the ecosystem as a whole. As we've heard from many of the speakers before, there is certainly a lot of environmental concerns around different types of deterrence. Just another thing to add, it's great to see how active the chat has been, so please continue to use that to ask questions of the speakers and to build connections. So first up in our deterrence and defense session, we've got Professor John Swaddle from William and Mary University in the USA, who will be discussing sound-based deterrence and his innovation around this method of control. John?
Thanks, Cameron, and thanks for the invitation to be here. So I'm a behavioral ecologist, and I try to sort of see these issues from the wildlife's point of view. So in this case, seeing this from sort of birds' point of view. And so we're working on some acoustic technology that may be successful in deterring birds from particular target areas. And so there's applications to thinking about this in terms of agriculture. Next slide. So we know that birds are pretty smart. They learn things pretty quickly. And we've been trying various different versions of a scarecrow for centuries, and they have very limited effectiveness. There may be some immediate effect of startling a bird, but in the long term, they will learn if there's no real threat, they will just come back, and sometimes even come back at greater numbers. Next slide, please. So to try to think about this in a different way, we want to understand from the bird's point of view, why they may be fearful in an area and not want to occupy a particular area. And one aspect of what we call their ecology of fear is that birds need constant information about what is around them to assess predatory risks. So if you're out there in the field for real as a bird, if your acoustic information, what you can hear is masked around you, their level of perception of threat goes right up, and they stop foraging and they become much more vigilant, and they'll leave an area. An analogy to this, if you want to click again, for us is sort of thinking about if you're in a city where you know there's a high crime rate, you're at night, do you want to walk down a well-lit road or a dark alleyway? Unless you're up to no good, you're probably going to go down the well-lit road because of your perception of threat. And essentially what we're trying to do is manipulate that situation for birds and make some areas deliberately scarier for them, but in a real way, because there are real threats on the landscape, by masking their acoustic information. Next slide. So what we've done over a series of different kinds of tests is develop a technology which is called the sonic net, which essentially is a sound that deliberately masks communication channels for birds. So broadcasts broad frequency sound through the communication channels that birds are hearing at and listening at. And if you spatially control that, what you can create is an area where the birds will prefer not to be, and they will be moved onto other areas. If you want to click again, they will be moved onto other areas on the landscape. So this has to be sort of seen as a landscape type of solution, where you're influencing the bird's perception of threat and risk in a specific area and then moving into another area. You're temporarily degrading their perception of habitat quality in a target area. Next slide. So we've tested this with a number of different species in a number of different kinds of contexts, and here are some of those results, looking at birds that flock in high numbers and cause crop damage. So the European starling and red-winged blackbird. And in various different field trials, we've had pretty good success and sustained success too as well. Habituation is the problem with a lot of these deterrent types of situations. And so far over the length of trials that we've done, including some trials that have been running for now over a year, we haven't seen habituation. We haven't seen a decrease in the effectiveness of this type of deterrent, because the threats are real. And if birds can't hear those threats, they will still continue to perceive that target area as being a risky area for them to be in. And as long as there is somewhere else for them to go that is nearby, that they can easily move to, then you will effectively displace them away from an area. So in field trials around airfields where birds cause problems with interactions with aircraft, and on farm fields, post-harvest and post-harvest and pre-harvest, we can see deterrence of these flocking birds. Next slide, please. So this is, I thought I'd show you a video of this working. So this is a test that we did at maize silage stores in Cornwall around dairy farms, where you'll see a large number of birds come in and feed from the face of this silage area where the tarpaulin has been pulled back. And then when the sonic net is deployed, the birds will disappear and you'll see a range of different birds. We monitor starlings in particular, but there are gulls in here and there are also crows in here too as well. If you want to click, hopefully the video will play. So this is where the deterrent is off. There's plenty of bird activity. They come in and they're feeding. This is time lapse, so you occasionally see a worker come in, take some food away to feed to the cows, and then the sound will turn on. Hopefully the sound will actually hear. Oh, I'm not hearing it. Well, it must be the way the webinar is set up, but the sound is on right now. Birds all disappear. And then when the sound goes off, the birds will return. So another advantage of this type of technology is that it's immediately sort of deployable and undeployable. So in terms of conflict with humans, you can just turn it off because human and bird hearing very much largely overlap with each other. So this would cause potential annoyance to people who are in that particular target area too as well. Click again, please. So with that, I'd like to sort of wrap up and just sort of phrase this as a potential way of thinking about the problem from the bird's point of view that gets away from just the immediate shock of a threat deterrent and thinks more about shifting the birds into a different state of fear and then moving them away at a landscape level type of solution. Thanks.
Thanks very much, John. What an interesting presentation and a really, really promising innovation there. So thanks for sharing that with us. Our next speaker is Aditya Paranjape, who has been looking at drone technologies and will speak about how drones can be used to stop birds from going into areas where you don't want them to go in various different contexts. So Aditya.
Hi, thanks, Cameron. Am I audible?
Sorry?
Am I audible here?
Oh, yeah, we can hear you.
Okay, lovely. Okay, so hi, my name is Aditya Paranjape. I'm full-time with TCS Research, but I'm also a visiting academic at Imperial College London and IIT Bombay. So I want to tell you a bit about some work that we did a few years ago about using UAVs for herding. Next slide, please. Okay, here's a really quick overview of the problem. I think we've seen and talked enough about it today. But the key point here is how Quelea move, and they move in flocks that are large, typically hundreds of thousands or occasionally even a few million individuals. Now that's obviously a challenge, but I'll also show you why these kind of large flock sizes can be an asset if we have to keep Quelea away from grain plantations. So the question that we want to possibly investigate here is how can we use robots? I mean, aerial robots is one solution, but also possibly ground robots to keep flocks of Quelea away from grain plantations. Next slide, please. So our idea here is herding, and the ample examples in nature. We've all seen sheepdog herd, basically herds of sheep away. It's also seen in marine mammals. So if you look at the figure on the right, you see how dolphins work. In this particular case, you have dolphins creating what is called as a horizontal carousel, just creating a round formation around a school of fish. And as the dolphins move, they move the school of fish with them. And then they can take them close to some sort of a vertical barrier and then actually start eating. Another thing that's been done in nature, not directly by the animals here, but it's using robotic birds to keep birds away. So for example, in the figure on the left, you see a robotic falcon being used at Edmonton. Now, this was an experiment carried out a long time ago, about 6 or 7 years ago. And I noticed in the chat window, some of the folks talking about carrying out similar experiments in Kenya. So using individual falcons to scare birds, individual birds or small groups of birds is also something that we've done. Next slide, please. So when we started working on this problem, this was back, I think, in 2013 or so, we wanted to see how you could move or how you could herd birds away. So what we mean by herding is you have a group of birds and they're simply deflected from their paths. We're not actually engaging directly with the birds, so there is no physical contact. We're not trying to scare the birds away. And we certainly don't want those flocks to break up, because once they break up, they are that much harder to control. So what we did was we started by modeling these flocks. So my background, by the way, is in dynamics and control. So I take a lot of interest in how these big groups of animals, or indeed any big group of agents, can be modeled and then controlled. And our model was based on a few principles which had been elucidated back in the 1980s by Craig Reynolds. And that was done, in fact, for creating computer simulations of flocks. But the basic idea is simple. In typical flocks, birds do tend to maintain more or less a fixed distance from their neighbors. These flocks tend to stick together as cohesive units to the extent possible. And this one point about cohesion is where large flocks become important, because if you have small flocks, small teams, they can be very dynamic in that sense. And the principle that enables herding is that when a drone of any form moves close to a flock, the closest members of the flock tend to move radially away from that drone. And that basically has a pushing action, if you will, on the flock. Now, the key thing here is you want to keep that optimal distance. You want to be close enough that these birds are actually scared of the drone and start moving away. But you don't want to get so close that the birds are something very dynamic. I mean, in some cases, if you move sufficiently close to a flock, the flock can start splintering locally. So it's maintaining the optimal distance that actually enables herding. And we basically did some of this mathematical modeling to see how you could use one or more drones to herd cohesive flocks away from their original flight path. Next slide, please. So we did, some of our collaborators in South Korea carried out experiments. And this first example is a fairly stereotypical demonstration. It was carried out on a bunch of egrets. And what you see here is, in fact, a series of pictures. So if you look at the pictures in the top row, you'll see a few red dots. I'm sorry, it may not be very visible here, but those red dots are the egrets approaching their nests, which are located on the left-hand side of every picture. There's a drone in those pictures that approaches egrets from the bottom. And as it approaches the egrets, you see all of the egrets actually move away, and their trajectory has been plotted in the figures in the bottom row. The key takeaway for us from this experiment was that the birds actually moved away from the drone as expected. So there was no unexpected maneuvering. That radial motion that we thought would happen did actually happen. And that group of birds was small, about 5 to 6 birds. It actually stayed as a single group of birds. Next slide, please. The second experiment sort of illustrates some of the hidden challenges that are associated with herding birds away. So here we had a rather large group of birds, or what we thought was a single group of birds. And when you look at the trajectories in the bottom, the dashed lines are the birds, the drones shown in blue. As the drone approached these birds, they deflected away just as we had expected. But when we looked at the trajectories closely, what we figured out was that the velocity profiles were actually different, indicating that what we had actually deflected wasn't a single flock, but actually about 3 to 4 different flocks. At that point, they were all sort of spatially co-located. And you can imagine that had we pushed this experiment further, some of these flocks would have actually splintered, and which basically means a single bird here, a single drone here would not have worked out all that well, but at least locally, it did its job. So the key takeaway for us here is, even when you have what looks like a single group of birds, how do you actually know it's a single flock acting as a unit and not actually a collection of flocks, which will start to splinter? Next slide, please. So some of the key challenges that we identified from that work, and there's also possibly interesting research directions for folks that are interested, is so we've investigated herding now for flocks that have no interest in the protected area. So we're talking about airports, for example. In some cases, they do have nesting grounds, but very often, like with geese, for example, they're just flying over the airport to get to where they have to go. Now, in this particular case with Quelea, we're talking about their feeding grounds. So the key question here is, how do they react when they're desperate for food and they're hounded by these drones? So that's one behavioral modeling that probably needs to be done. The other thing with these drones, now this has to do with applying drones not just once or twice, but on multiple instances, one after another, to herd Quelea away. I saw a fascinating BBC video a few weeks ago about how Quelea roost together in the at nighttime, and it's during the roosting session that they actually exchange information. And that shared intelligence can actually modify their behavior, and we don't actually know what to expect from it. So what we see in nature, for example, is divide and conquer. Sometimes small teams of birds will simply split up. We don't know if that happens with Quelea flocks. But once they split up, basically that group as a whole is unmanageable. So one group might actually be able to feed now, and another group can feed later. The other thing we see in large groups, especially with fish, as you see in the figure in the bottom, is they start to mill around the predator. So in this case, as a single shark approaches the school of fish, they start just circling the shark, and the shark basically, as it moves closer to the group of fish, the fish just move with it as a single wheel that's going around the shark. And that obviously means this kind of herding may actually not work all that well. The other thing that we also see occasionally is aggression towards the drones. So as you see in the figure in the right, you have a falcon, and the falcon attacks a drone that actually got on this occasion too close to its nest. And again, we expect this with Quelea because effectively we are not moving Quelea away from some neutral territory. That territory does happen to be their feeding ground. So I think the key takeaway for us is, A, how do we move Quelea away? But also, how do we identify their behavioral strategy? Because ultimately, everything else that we do with regards to control is contingent on our understanding of their strategy. So I'll stop there, and thank you very much.
Thanks very much, Aditya, for another really interesting presentation on another very promising innovation. So unfortunately, we did have a third speaker lined up for this session, but they were unable to make it today. We would have been hearing from Dr. Giovanna Masai on contraceptives and how they're used for pest control. But we will put a link into the chat to the Botswana Institute for Wildlife Fertility Control at the University of York, which is where Giovanna works. And we will allow you to sort of use those links to read a little bit more. So next, we're going to go on to a discussion session, a networking session. We're going to...
We get going. So hopefully some interesting conversations were had during that networking session. We've got 2 more talks now, and then a further networking session to finish off the event. So please do continue to put any questions you've got in the chat, any final introductions there too. So this final session is going to focus on the actual crops that we grow, and how we grow them and manage them could impact the extent of damage that Quelea birds cause. So our first speaker for today is Ephrem Habyarimana, who is a principal scientist at ACRE. And he's going to speak to us about the role of crop breeding in preventing loss, and particularly focuses his work on sorghum breeding. Ephrem, are you back with us?
Yeah, thank you. Will you manage the slide from your end, or?
Yes, we will. Yeah, the slides are up now.
Yeah, this is the title, and of course, thank you for presenting me. And good morning or good evening, depending upon which longitude you are. So I will talk to you about application of genetics to try to control bird damages in sorghum. Next slide, please. I will start briefly by introducing to you ACRE. ACRE is the International Crops Research Institute for Semi-Arid Tropics. This is an international organization, and it is headquartered here in India with a global presence in Asia and in Africa. And we do reach to more than 2.1 billion people distributed in the cropland of the world. Next slide. Yeah, briefly how ACRE creates an impact. ACRE is working on 6 mandate crops, including legumes and the cereals. And among cereals, we have the sorghum, which is a major crop. And we have, as we speak now, we have shared with partners across the globe more than 360 variety of sorghum. And these were distributed in more than 46 countries across the globe. Next slide. Yeah, talking about sorghum, sorghum is among the cereal crops most vulnerable to bird damages. And in sorghum, tannins, these are phenolic compound, are among the compound that helps sorghum or help farmers prevent bird damages in sorghum. These tannins are concentrated mainly in the pigmented tester and in the pericarp of sorghum kernel. Next slide. talking about tannins accumulation in the kernel, now the genetics of tannin accumulation is well known in science because we have, for example, these B1 and B2 genes. When they are expressed in the plant, it does mean that the tester layer is pigmented, and then when it is pigmented, it does contain tannins, and the concentration of tannins can be modulated genetically by playing or expressing the gene called an intensifier gene, for example, or the spreader gene, or the gene responsible for the thickness of the pericarp, and also the genes that are responsible for the color of the test area. All these genes can be genetically manipulated using conventional or modern breeding techniques, and then this would result in varying levels of concentration of tannins in a kernel, and these genes can be also introgressed in elite cultivars that are mainstreamed in any given ecology, and then try to reduce somehow the damages from the birds. Next slide, please. Yeah, there are some other structures of the kernel, like, for example, awns or large glooms or compact heads or head or panicle, or the phenotype that we call gooseneck. These can be structures that are constitutively expressed in the plant that can combine with the tannins I described earlier, and this combined can just help the farmer or the producer or the grower reduce the bird damage. You can see, for example, the tannin 1 gene that can be manipulated and introgressed in any cultivar background, and that this can just help reduce the damages, and the grain shouldn't be necessarily look yellow or purple. This can be also introduced in white grain because the tester is just under the pericarp. The grain can look white, but with a pigmented tester and with the same or similar effect about the repellent capability of the kernel. So, but one word of caution here is that there is no genetic means that can prevent bird damages 100%. All these structures and genes can just reduce the damages, and but when there is no alternative food in the environment, then to survive, the bird will just feed only also on the otherwise undesirable source of food. So then on this note, what we think as a breeder, we think that it is a time to think about integrated bird management system that can integrate not only genetics or plant physiology, but also landscape level interventions, like, for example, coordinated planting, because when a coordinated planting is done, it does mean feed availability is sufficient. And when the food availability is sufficient, then at individual farm, the entity of damage can be just reduced or contained. Other aspect is, for example, leaving bird habitat integrity. This is very important, so that if you destroy, for example, the habitat, the bird will be just desperate and move, and as they move, they also wreak havoc on the plant. So this is our conclusion right now. Next slide, please. So let me finish with some pitch of our sorghum hybrid parent research consortium here at ICRISAT. This is a very strong platform through which particularly private seed company can get, next slide please. A private company can get superior varieties and hybrid from our institution. So I am the head of sorghum breeding, as I told you, and through myself, you can see the email in the lower right of the slide. If you have just any desire to know about this consortium, you can just reach out to me, and I will provide you with further details and how to join this consortium. Thank you so much.
Thank you very much, Ephrem. Really good overview of some of those breeding methods for looking at sorghum. So our next speaker is Jonne Rodenburg, who joins us from NRI, a UK-based university. I'm actually going to take over the control of the screen share to share your latest version here now. Over to you, Jonne.
Yeah, okay, yeah, I was planning to control the slides myself because I have a, but let's do it this way. So my name is Jonne Rodenburg, and I'm a professor of agronomy at the Natural Resources Institute at the University of Greenwich. It's the same organization as the first speaker, Bob Cheke. So next slide, please. So I'm going to first talk a bit about work that we have done in rice. We have tested different treatments, mainly weed management, and two different rice varieties. So on the right, so this is done in the Senegal River Valley, where there's lots of rice cultivation, irrigated rice. And on the right-hand side, you can see an experimental setup with the two rice varieties, and then weedy, those are the grape plots, and weed-free, and those are the netted, sorry, weed-free, the white plots, and then netted and unnetted plots. Next slide, please. So here, could you please click? So here there are, we have done different, we have done bird counts at different times. And so the red, the green circled ones, the open symbols, they are the weed-free plots. And then the purple ones are the black, the filled ones are the weedy plots. And you can see that at different times there are different bird visits. So there are much less bird visits to the weed-free plots than to the weedy plots. But if you go later into the timeline, so later into the crop cycle, then this difference sort of disappears. Next slide. So there's a clear delay in the number of, or in the bird visits when you look at weed-free plots, and potentially there's also a reduction in the total visits. Next, please. So in overall, we can see that in different years, in terms of the relative yield losses, there's often, well, the weeds are responsible for often higher yield losses than birds, but this depends on years. Next slide, please. And there is a difference between the shorter cycle variety and the longer duration variety. So Sahel 108 is a short duration variety, and the Sahel 202 is the long duration variety, but the difference between those is not consistent. So in 1 year you will have lower bird losses, bird-related yield losses in the short duration variety, and in other years in the long duration variety. So that is inconsistent. Next, please. So if we look at the yield losses, so in this table you can see the yield losses because of the weeds in the first column, and in the second column you see the relative yield losses because of birds, so in weed-free, and then in the third column you see the relative yield losses with when rice is exposed to both weeds and birds. Now you can look at the relative yield losses in two different ways. You can look at the difference between the relative yield loss of weeds and birds combined minus the relative yield loss of the birds of the wheat only. And then you see that that it's, well, from this it seems that the birds seem to cause less damage to a weedy compared to a weed-free field. Next, please. Next, please. But the thing is that birds only eat the grains after the damage has occurred because of the weeds. So you would actually, please go to the next slide. Next. So you actually you have to actually look at the relative yield losses because relative to the already weed infected yields. And then you see that the relative yield losses are actually much higher when the relative yield losses because of the birds are actually much higher when you are looking at plots that are weedy. Next, please. So we've also done a modeling study, and we have seen that the bird inflicted yield losses, they increase from 44% in weed-free conditions to a maximum of 55% at the critical weed infestation level. Next, please. So from this study, we have concluded that weed control can reduce bird visits and also bird damage in rice. The role of the cultivar is less obvious. In some years you have lower yield reductions with shorter duration varieties, and in other years you have lower yield losses in longer duration varieties. And we've also seen that there is a component of the sowing date of the rice. Next, please. Now, I'm also interested in sorghum, but in sorghum, the weed management effect in terms of bird visits will be less likely to contribute much, because sorghum is of course a much taller crop. Next, please. So here we could look at, like the previous speaker has talked about, the role of sorghum varieties. You can look at grain color, taste, and size, variation in grain glooms, but also panicle types. So on the picture below, you can see different panicle types of sorghum. And for instance, the Dura variety N13 has been reported to be less attractive because of the banded panicle. But more interesting perhaps is even the maturity time, long versus short duration. Next, please. So the short duration varieties, they may avoid the bird attacks, but more importantly, reduce the length of the bird exposure, because you never know when the birds will attack, of course. Next slide. So additional agronomic and agroecological measures. So because the Quelea birds, they prefer wild seeds over cultivated, so you could think about diversified field margins, growing taller lure grass species around the cropped area, but that is mainly feasible for the shorter crops like rice and not so much for sorghum. You could also think about crop rotations. They may require a community coordinated approach. So if you grow crops that are not attractive to birds in 1 year, and then you alternate that with the crops that are attractive to birds, then perhaps you can introduce an element of unpredictiveness. Intercropping with a repellent cover crop, that's a very blue sky idea, has not been tested yet, and may also be not very effective, but we have to test it. And also, well, for me, I think the most important thing is looking at the timing of crop establishment to avoid that the milking or dough stage coincides with the arrival of migrating birds. So this also may require a community coordinated approach. Most often it requires irrigation facilities, because you cannot choose the growing of the crop cycle. You cannot choose the timing when you are looking at rain-fed crops, obviously. And this could also be combined with shorter duration cultivars. Netting is effective but expensive. Next, please. Oh, this doesn't work for some reason. Oh, previous, please. So there's no measure. None of the measures will provide an ultimate solution ultimately. And the range of options is also a function of crop and growing environment. So if you talk about a tall crop or a shorter crop, that depends also what you can do in terms of the field margins, for instance. And also if you are growing in an irrigated environment or a rain-fed environment. And so an integrated control strategy is preferred. So I'm very interested in, could you please show the whole slide? I'm very interested in testing all these kind of things, cultivar screenings, looking at lure grasses in field margins, community-based crop rotations, timing of timing experiments, timing of planting, synchronization of planting within communities, farming communities, and then combined with long or short duration cultivars to see how that works out. And ultimately, I'm interested in integrated Quelea control strategies, doing that in a farmer participatory manner and in a community-wide type of research. Thank you.
Thank you very much. And so that concludes our talks for today.